Alright, time for another draftphysics.com, debatephysics.com also. Video presentation. So far I haven't been able to find any debaters, any physicists willing to defend their precious theories and beliefs against this critique that what they're arguing is impossible, problematic, let's see, there's probably some other paradoxical, yeah, that's a fancy word, that it can't be true because if you take it to its logical conclusions, it creates circumstances that we know can't happen. Because if they did happen, we'd capitalize it and all have free energy, that kind of thing. So they contend that if I'm throwing a ball against a wall and the wall moves, it doesn't matter. Yeah, that's what they're really saying. You could understand that. Let's say the ball, let's say we go to the Newton's cradle. We have two equal things, two equal objects, and they hit each other, and one of them flies away with all the energy, and the other one has nothing. All right. I make this one just a tiny bit heavier, or lighter. I make this one a little bit heavier. And then I crash it in. Well, the fact is, all the energy is not going to get into this one because it's not the same masses anymore, and they can't do the nickel for nickel thing. They have to convert nickels into dimes. Well, anyway, it won't happen, and you'll get a little bit back. And the heavier I make this thing, the more I get back, until I get to some infinite point where this is very massive, and I get all of what I put in back. Okay, essentially all. Close to it in the idealization. 250 worth of reflections all, in the sense that it'll keep bouncing off the thing, and every time that happens they're saying twice the momentum goes into the thing, the big thing. And obviously you can understand that no, this is like a tennis ball and you throw it against a brick wall and you get most of the energy back, and then you throw it at a piece of plywood or something that wobbles and you don't get nearly the amount back because you put it in. If it moves, you've lost it. Okay, you've used the energy. If this thing moves when you hit it, that's losing the energy, and you're not going to get the energy back. All right, that's the simple explanation. All right, but this is something they assert is absolutely true, and like I said, there's kind of simple descriptions that point out it can't be true. So I've been doing a lot of reading of the ancients and trying to see how this mistake was ever made in the first place. And the ancients did bring up ballistic pendulums and how in all the inelastic circumstances, all the kinetic energy or a substantial amount of it disappears. And that they can say it's internal, but they're just saying that. And they would even make comments about Leibniz's mystical monads or something. And the fact is that, yeah, you can't argue for energy you can't find or demonstrate to exist. And so they bring up levers and a couple of other things, but it was in some sort of always a more complicated way, let me say, than is, I would think, necessary. So it wasn't illustrated very well how it fails. But the argument was clearly made that Leibniz was preaching perpetual motion. And he actually did suggest that he had found a possibility of perpetual motion in the living force theory. So let's understand that the origins of this thing are dirty, okay, and corrupt by really bad ideas or notions of reality. All right, so I think this experiment, if it could have been argued, but they couldn't argue space examples perfectly because they all assumed things about space. They didn't know it about space. But we know that if I put two things in space the same distance apart, they're just going to stay there for a very, very long time unless a force acts on them. Okay. And so the idea would be is that you're going to do that. You're going to create that force, and I'll just use 100 momentums again as a idea. Something 10 velocity going 10 meters per second. Let's see, that'd be 10 times 10 is 100, times 10 is 1,000, and half 500. No, so I have to do something like 10 times 5. So it's a 10 mass going 5. That'd be 125. Well, anyway, you get the idea. It has 100. All right, and I put it in, and I have it hit one of these objects at a much straighter angle. Just imagine you can do it at a very straight angle, and it's just going to bounce back and forth, back and forth, back and forth, back and forth. So these are very heavy. So you could even argue 1,000 times more massive. So you almost have the bullet and the recoiling gun. So it's just going to bounce back and forth. And the fact is because this is 1,000 times the mass, okay, and it will, they're arguing it will move. Now I'm going to argue that it probably won't because they're too massive and they can't absorb any of the motion because it's not in small enough denominations. So it basically just goes in as a vibration, comes back out and says, I reject thee. Okay, it doesn't absorb any of the energy. But taking their theory that it does absorb 2x. So for every single impact, twice the momentum. And you're getting back, let's just say it's 99%, whatever, in these reflections. Then you can understand that after 100 reflections, you're going to have a huge amount of momentum in both of these objects. Okay, it'll be 100, plus 100, plus 100, plus 100, 250 times. You could do that maybe. And so you're going to have stuff with a momentum, in the thousands, okay, moving and double it because you got two sides that are doing the same thing, rejecting the energy, frankly, and yet they're claiming it's absorbing twice as much energy. Right on its face, you're saying, okay, I put 100 in and somehow I got 300 out. And then as it just keeps bouncing, it's just going to keep adding that 100. Because the velocity of the heavy thing, remember, it's going to be very, very slow. So there's always going to be a big difference between the velocity of the reflecting object and the object it's hitting, 1,000 to 1. So, clearly, this demonstrates that you can't make free momentum. You can't make these things go with a tremendous amount of momentum and then believe that you can't make a lever or some other object to convert the really heavy, high torque object into a very small, high velocity object, when of course you can. And you would end up with an object that had 1,000 momentums and you only put in 100. So, I mean, I'd argue this is, a logical proof. Now, some physicists can point out how any of what I said here doesn't happen, that you don't get, say, a 99% reflection with a steel ball or a glass ball off a hardened steel anvil. Let's say these are hardened steel anvils, and that you won't get these results. And, of course, this is exactly what will happen. So, or can they draw this and explain how something else happens, that this doesn't reflect with 100%, and it doesn't reflect off this one with nearly, 99%, and it doesn't reflect off this one with 99%? I mean, you don't get this huge increase in the total momentum in space. I mean, this is your total. You're going to have 4,000. You put 100 in, you got 4,000 worth of pressure in the universe. Mass moving with a capacity to impose pressure. The capacity to impose pressure is the same thing as saying force or energy, because all I do is push that against some mechanism like a piston, and I can create hydraulic pressure in any velocity I want, just by changing the ratio of the size of the pistons. I can put it through a gear, I can put it through a lever, I can put it through pull on pulleys. I can do all kinds of things to convert this very low velocity, high momentum into a very high velocity, small mass momentum. So it's free energy, plainly. It plainly can't be true because we'd exploit it if it were, and have much more efficient mechanical devices. We'd have perpetual motion is what we'd have. We'd have perpetual running machines that we could keep excreting energy out of. It's producing, we put in 100, it produces 4,000. Even if we only collect 2,000, we only need to collect 1,900 of that we can have for free, and we only put 100 back into the machine. If the machine feeds on only 100 and it's producing 4,000, you can understand that, yes, that's perpetual motion and perpetual energy. And obviously that doesn't happen in this universe. So I really shouldn't have to keep making all these arguments. But this is the direct consequence of their 1/2 mv squared silly nonsense theory, okay, is that it creates this paradox. And their idea that there's such a thing as negative momentum creates this paradox. That somehow, when two things are moving in opposite directions, that they cancel each other. That their total energy is the product of subtracting the two motions. So again, I hit the pool cue ball into two balls, and they bounce off it at vectors that have a huge opposite component. Somehow I'm supposed to subtract that opposite component, and somehow the remaining energy will be conserved, and it clearly won't. You won't conserve the momentum that way. Subtracting momentums will not conserve momentum. All right. Should be enough. Longer than I was hoping, but whatever. So I think this illustration would have been enough proof in a time when people weren't invested, when they were still seeking the truth. But now that physicists think they have the truth, and they've written a whole bunch of other equations using this v squared, and they're really they have to change an awful lot to get rid of it. A lot of silly notions have to disappear. A lot of other silly notions. Obviously, they're invested, and so they're not honest brokers anymore. They're not honest players in the game of truth. So if it could have been demonstrated 200 years ago, there would have been hope that reasonable people would say, yes, I understand that can't be true. That whatever motion is absorbed by this object, it can't reflect 100% of the energy it had if it puts some into the object. Whatever it puts into the object is energy it doesn't have anymore. All right. Is momentum it doesn't have anymore. After the tight end hits the quarterback, he can't keep his momentum because he gave it to the quarterback. I mean, it's that simple an argument. You can't keep what you gave away. Oh, you have to really, I mean, it's that silly. I have to say that to adult humans who have taken maybe 6 years of scientific education. I have to explain to them that you can't keep what you gave away. Yeah, that's pretty sad. That's scary sad. That's what's called depressing.